So here we have the identity cosine of 2x is equals to cos squared x minus sine squared x. So let's try to prove it by using the Euler's identity. So we're going to start from the right hand side. So we have cosine squared x, so that can be written as cosine of x whole squared minus sine of x whole squared. Now we're going to substitute cosine of x with its Euler form, which is e raised to the power of ix plus e raised to the power of negative ix over 2 whole squared minus e raised to the power of ix minus e raised to the power of negative ix over 2I whole squared. So we have e raised to the power of ix whole squared plus e raised to the power of negative ix whole squared plus 2 times e raised to the power of ix times e raised to the power of negative ix over 4 minus e raised to the power of ix whole squared plus e raised to the power of negative ix whole squared minus 2 times e raised to the power of ix times e raised to the power of negative ix divided by 2I whole squared, so that will be 4I squared, which gives us e raised to the power of 2ix plus e raised to the power of negative 2ix plus 2. Now since e raised to the power of ix is the conjugate of e raised to the power of negative ix, so the product will be equals to 1 divided by 4 minus e raised to the power 2ix plus e raised to the power of negative 2ix minus 2 divided by I squared is a negative 1, so we have negative 4, so that will make it positive. Now let's combine the two terms in the numerator. So we have 2 times e raised to the power of 2ix plus 2 times e raised to the power of negative 2ix plus 2 minus 2 divided by 4, which gives us 2, let's take the 2 as the common term, plus 2 and negative 2 gets cancelled, 2ix plus e raised to the power negative 2ix all divided by 4, which can be rearranged to write it as I or e raised to the power of I times 2x plus e raised to the power of negative I times 2x divided by 2, and this is the Euler's form of cosine of 2x. So this proves the given identity, which is the left hand side.